So the next question, if the ninth term of an arithmetic projection is 5 times the fifth term, find the relationship between the first term and the common difference. So they told us that the ninth term is 5 times the fifth term. And you remember that the ninth term is a plus 8d. Do you remember? A plus nth term is a plus n minus 1d. So 9 minus 1 is 8. Why this is 5 times a plus 4d. So we'll solve this. So that's from what we are given. So we'll form an equation of this form now. So we now expand the bracket. This 8a plus 8d equals 5a plus 20d. So we'll collect like terms. So 5a minus a is 4a. Y 8d minus 20 is minus 12d. Minus 12d. So what is common is 4. So 4 in 4a is a. 4 in here is minus 3d. So that's the relationship. Or maybe depending on if it's an OB, they might write it a plus 3d equal to 0. So anyone that are correct. Or d equals to minus a over 3. So that's it. So the next question, the sum of the first 80 positive even number is dash. Without wasting time, is always 80 square plus 80. That's the answer. So the answer should be 8 square 10 64. That's 648. That's our answer. Without wasting time. But let's prove it. The sum of the first positive n. Okay, let's just end sum of the first n positive even integer. So from our even number is always starting from the first positive even number is 2. The other one is 4. Do you get? So to n. So to n. So we will now form an AP with what? Remember, we have to find the sum. We'll form an AP of first term. A is 2. Y, the common difference is D is also 2. So from our sum of the first n term equals n over 2. 2a plus n minus 1d. Do you remember the formula? That's n over 2 plus first term plus last term, but we don't know the particular last term. That's why I use this. So we have n over 2. A is 2. N minus 1. Common difference is also 2. So open up. So if you open up, this times this is 2n. Why this times this is n minus 1 times n. So if you open up, this is 2n plus n squared minus n. So my answer is n squared plus n. So do you see it? So our n in this question is 80. So the sum of the first 80 positive term is now positive even integer is now 80 squared plus n. So you don't need to waste time. Also for odd, doing the same thing for odd, the sum of the first odd number, n odd number is n. So for odd, first odd is n squared. So you have to check it later on your own using the same method I used. So the next question, the sum of the first n terms of arithmetic projection is n squared minus 1. We have to find the common difference. If you could remember that the nth term is related to the sum of the n term minus sum of the n minus 1th term. Do you remember from the previous video? So they gave us, which implies that since Sn, remember the sum of the first n term is n squared minus 1. So the sum of n minus 1 term is now n minus 1 squared minus 1. So we have n squared minus 2n minus plus 1 minus 1. So I have n squared minus 2n. So the next thing is now to subtract. Therefore our nth term is now n squared minus 1 minus n squared minus 2n. N squared minus n squared is 0. Minus 1 minus 2n is now 2n plus 1. Sorry, 2n minus 1. 2n minus 1. But we are not asked to find the nth term, we are asked to find the common difference. So do you remember that common difference is also 10n minus 10n minus 1. So I will now have 2n minus 1 minus 2n minus 1 minus 1. Do you get? This is the nth term, which is 2n minus 1. So n minus 1 term, wherever I see n, call it n minus 1. So that's how we got this. So we open up the bracket. So we have 2n minus 1 minus 2n minus 2 minus 1. And this will be 2n minus 1 minus 2n minus 3. So open up 2n minus 2n is 0. Minus 1 minus is now minus 1 plus 3, which is 2. So the answer is, our common difference is 2. So the question is tricky. Relates the sum of the nth term and also the common difference. So you need to remember this formula. So the next question, we are given if x, y, and z are consecutive terms of an arithmetic progression, and if x plus y plus z is 24 and x, y, z is 440, then x, y, and z are dash. So we are given this. So from the question, they told us this is an arithmetic progression and there are consecutive, x, y, and z are consecutive terms. So since we are given that x plus y plus z is 24, we know that consecutive terms differ, but let the common difference be d. So you notice that x plus y is x plus d. Do you get? Since they are consecutive terms, the common difference is d. Yz is x plus 2d, because they told us that consecutive terms, so they will always differ by each of them. That's each consecutive term differs by d. So that's it. So we add. We have x, so we have 3x. D plus 2d, 3d equals 24. So what do you have? 3 is here, 3 is here, 3 is here. So we have x plus d. That's the common term is 3, 8. So that's what we have. So s plus d equals 8. Equation 1. But they told us that the product x, y, z is 440. So which implies that x plus x times x plus d times x plus 2d must give us 440. Yes, since the y is x plus d, yz is x plus 2d. So we substitute, because from the equation 1, x plus d is 8. So I have x times 8. And inside s plus 2d, we have x plus d. 2d is d plus d. So we have x plus d, which is now 8 plus d. You understood what I did? S plus d is s plus 2d. So s plus d is 8. So I have 8 plus d. So again, from this you notice we have common 8 can go 8 here off, so we have x times 8 plus d. Why 8 here is 55, so I divided both sides by 8. So again, from equation 1, s plus d is 8, so meaning x is 8 minus d, so I substitute x as 8 minus d. 8 plus d equals 55, because x plus d is 8 from equation 1. So that's why we now substitute wherever we see s, call it 8 minus d. And looking at it, we have difference of two squares, so we have 8 squared minus d squared equals 55. So d squared is now 64 minus 55, because 8 squared is 64, and 64 minus 55 is 9. So d is plus or minus 3. So our common difference is plus or minus 3. So our x now from equation 1, therefore x is 8 minus d, and d is plus or minus 3. So we have either 11, s could be 5 or 11, so depending. So you choose any one and now use. So since x is 5, implies that y is 5 plus d, and d is what? 3. I'm using 3 when d is 3. So I'm using 3. So wherever you see y is s plus d, which is 5 plus 3, we have 8. So z is now 5 plus 2 times 3, which is 11. So the terms are, therefore, is 5, 8, 11. Again, if you try to use d as minus 3, so 11, our first term will be 11, so you still have the same thing. So if you, after doing it, you still get 11, 8 and 5, which is still correct. So using d as minus 3, so the value is 5, 8 and 11. So that's our answer. The next question, we are given if 3 plus 5 plus z plus 7 plus 9 plus x plus plus x equals 4, 6, 2, 3. We asked to find x. Looking at this is an arithmetic progression with common difference. This is an arithmetic progression of common difference, which is 2. First term is 3. Last term is x. And finally the sum, because they gave us the sum of the first n term is now 4, 6, 2, 3. So with this information, we'll now find the value of x. So, and they told us the sum is 4, 6, 2, 3. And remember, sum of the first n term of an arithmetic progression is always n over 2, first term plus last term. Yes. But the problem here, we don't know the value of n. So we need to find n. From this, do you remember that the nth term equals a plus n minus 1 d? Implies that our n is now 1 plus last term minus first term over d. That's making it the subject of formula. So which is now 1 plus the last term is what? X minus the first term is 3 over the common difference is 2. So we substitute wherever we see and we call it 1 plus what? X minus 3 over 2. So we now go to this equation. Therefore our sum, remember sum is 4, 6, 2, 3 equals, what is n? N is 1 plus x minus 3 over 2. over 2. Remember, this is for n. Finally, our first term here is 3. Our last term is x. So let's now find the value of x with this equation. We have an equation and the unknown is x. So let's find it. So here we'll cross multiply because 2 goes here 2 times 6, 4, 2, 9. So I say I cross multiply 2 times this. That's 4, 6, 2, 3 times 2 should be 6, 4, 2, carry. Okay, that's it. Why here is here we have 1 plus x minus 3 over 2 times 3 plus x. So the next thing, let's expand the bracket. But before we expand the bracket, the LCM here is 2. So 2 plus x minus 3. Yes. 3 plus x. Again, we can still, this is 9, 2, 4, 6. We can still move 2 to the other side. So 2 times this is 2, 9, 4, 18. So that's 2 times 9, 2, 4, 6. While here we are left with 2 plus x minus 3 times 3 plus x. And what is this to this? So this should be x minus 1 times 3 plus x. While here is 18492. So it seems this is turning into quadratic equation, as you can see. So we can write it as this is 18492. So this times that is 3x. This times that is plus x squared minus 3 minus x. So we have this is a quadratic equation now. So we have x squared plus 3x minus x is plus 2x. So I'm moving everything to this side. Minus 3. So we have minus 18495 equal to 0. So I'm just move this to the other side. So I have x squared here, 3x minus x, 2x. Why the minus 3? This one comes. So minus 3 minus 18492 is minus 18495. So I think if you factor it, this should be this plus okay, should be x plus 137 times x minus 135, because 137 times 135 is 18495 equal to 0. Therefore our x is 135 or minus 137. But there is a problem. Remember, from this is an increasing sequence. So it can never be minus 137. So the only answer is this. So this is the only answer.